Okay, I think we're ready to go. Hello. Welcome, everybody. Come on in, have a seat. I'm Dan Smith. I work on Java language features on the Java platform group at Oracle. Today, I'm just going to give you a whirlwind tour of all the great stuff that has come in the last 8 years or so, and then look forward to the next 8 years and what we're working on. When I'm working on a particular feature, and I haven't worked on all of these things that I'm gonna touch on today, but any individual feature, it kind of seems like a slow process. You have an idea and it turns into a proposal for something concrete that can actually fit in with the rest of the language, and then it goes through reviews and proposals and JEPs and specifications and all that. Takes a long time, and then you get to preview features, and a preview feature is going to iterate for a few times. The point being, when I'm focused on individual features, it seems like progress is slow. But looking back at all this great stuff that's come in the last few releases, it's kind of overwhelming. I have a ton of slides. I'm not going to be able to spend enough time on any of them. But my goal is to just give you a sense of what's in there, remind you of things you may have forgotten about or you may not have heard about, and encourage you to go take a look at them. I want to do a quick survey here if I can. Maybe we can get the lights up for a minute. I am curious about where people are at on Java versions, so I know if I'm talking about here's something you can use or here's something that you're going to be able to use in the future. Can I just have you raise your hand first of all as a baseline if you regularly write Java code? Okay, is that most of us? Most of us. Okay, keep your hand up. Keep all those hands up. Put your hand down if the code that you write usually cannot use Java 17 features. So put your hand down if you're on an older version. Keep your hand up if you can use Java 17. Okay, how do we do? I feel like we lost maybe a quarter of the people or so. Okay, now again, keep your hand up if you can use 21 features. Okay, how about 25 features? Okay, so not a ton of people using 25 features today. Sounds like maybe the majority, around 17 or 25 for a lot of your coding. So, okay, that's good to know. Some things. As we introduce new features, prime directive is we don't want to disrupt the language or make it feel like something that it's not. So we want to preserve the feel of Java. We want to make it easier to work with immutable data, not just primitives and strings. In sort of early Java, you had primitives and you had strings, and everything else was sort of mutating things with primitives and strings. We want to make it easier to have richer kinds of immutable data. More declarative, less imperative. More emphasis on saying what you want rather than how to go and compute it. There's different kinds of features in Java. There's primitives and references. There's arrays and there's classes. Different things like that where different sets of features are applicable in different rules on the two sides of the divide. And where we can, we'd like to smooth over those divides. And then just in general, reducing activation energy. What I mean by that is make simple things easy to do in a simple way. Not have a lot of extra overhead just to get started or to say something simple. Here is an example of all the slides you're going to see from here on out. So again, the goal is just to illustrate. Here's a feature. Here's some sample code. I point to the JEPs. Really encourage people, if you're interested in something, that's the first place to go. Google that JEP number. Go read about it. In recent years, there's been a lot of effort really put into polishing up those documents, making them accessible and useful to any Java programmer who wants to go and learn about the feature. Written by the engineers that worked on the feature and designed it. So take advantage of those. Anything you're interested in, go look at that. I've highlighted the new features in blue, so wherever you see something blue, that's something new that you couldn't write before. And then the top right corner, Those are the different versions. And so the grayed out 11 means this feature is not available in 11. It is available in 17 and so on. All right, so let me get going. Let's start with 17 and 21. 5 really big important features here. We've got text blocks, we've got switch enhancements, sealed classes, record classes, and patterns. I could spend 15 minutes on any one of those, and I can't because there's more than 3 things on the list. So we'll just spend a couple minutes on each one. Here's text blocks. A text block is a string literal, except that it can spread over multiple lines. And it can also include quotation marks inside of it. So the delimiter is 3 quotation marks in a row instead of a single quotation mark. The contents of the text block, often you're gonna put some code in there, some HTML or SQL in my examples, or whatever. Any sort of big chunk of text. That could be a string literal. There's some special treatment for white space. So I've got a little box here. Everything in between the delimiters is sort of the content of the string, but then it gets some processing, which tightens it up into that gray box around the text. So trailing white space, indenting white space, that gets thrown away. And the idea here is just that this is some text that's going to appear in an arbitrary place in a program, and so it's nested somewhere, and we want to just extract the essence of the thing. So there's some white space processing. You can read about that in string.strip indent. There's still escapes inside of text blocks. You don't need to escape your quotation marks, but you may need to escape other things. There's a couple of new escapes that are introduced. One is the backslash with a new line, which, like in a shell script, means just ignore this subsequent new line. And so the actual string content will not include it. And there's a backslash s, which just represents a space character. The reason you'd use that is because I talked about cleaning up all the white space. That backslash s is not considered white space. So if you need a space character for some particular reason, it's useful. And then I note, sometimes you want to add something or concatenate text blocks, and it can be awkward to take 2 big text blocks and concatenate them together with pluses in between. So APIs like string replace or format or formatted are good fits for injecting some string, with the usual caveats about be careful when you're injecting strings into code that's going to execute. Okay, next one, switch enhancements. Switches are weird. They're kind of a fundamental concept in programming. Take a value and do case analysis over it and handle all the cases. But the Java switches that we inherited from C are very low level. They're sort of go-to oriented. You've got a block of statements and you jump to a particular place. And then you just keep executing. And the only way to end the execution is to break with a break statement. So we added some features to switches. The first one is the arrow symbol, which has an alternative to just a colon and some statements. The arrow says, do the thing to the right of the arrow, and then you're done. So no fall through, just execute the thing. The thing can be an expression, or it can be a block. It can even be a throw statement. It's sort of inspired by the syntax for lambdas. And there's also this support for multiple cases, add a comma. The other thing that is added here is switch expression. So often what a switch wants to do is just map an input to an output. And when you're doing that, if you do that through assignment to a variable, there's all sorts of opportunities to mess that up or to mutate it incorrectly. With a switch expression, you've got an expression that produces a value. And so here I'm assigning to an integer based on the output of a switch expression. When you're doing that, a couple of special things. One is the ability to, when you're in a block, you need to produce a value somehow. It's not exactly a return because there's no like control being returned anywhere. So there's the yield keyword that says, here's what this block produces for this expression. And the other thing is that it's required to be exhaustive, because if you miss a case in an expression, then the expression doesn't evaluate to anything, and the expression needs to evaluate to something. So I had to add my Saturday and Sunday cases to this switch where I'd left them out from the switch statement. Next one, sealed classes and interfaces. So traditionally in Java, you've got two choices for extension. You can say a class is final, which means no one can extend it, or you can not mark it final, and then anyone in the world who can see the class is able to say they extend the class. Sealed classes provide a space in between so that you can share a type with users, but you don't need to share the capability to extend the type. It works for interfaces and it works for classes. Key idea is just that there is a list of permitted subclasses that comes with the class. You put that list in the header. If all the classes happen to be in the same individual compilation unit, you can leave out the permits and it gets inferred. And then two things. One is only those classes can extend, in this case, can implement the interface shape, only those three cases. And that's true at compile time. It's also a hard runtime guarantee. When a class gets loaded, that list is consulted, and if you're not on the list, you're not allowed to load a class that extends or implements the interface. The other thing is it's part of the API. So I'm communicating to the world that all the shapes you're ever going to interact with are one of these three things. And so that's a really valuable abstraction mechanism. Anybody who is operating on a shape knows that those are the cases they need to handle. And then one quirk about sealed classes is once you've declared a class sealed, all your subclasses need to declare how they can be extended. Often the answer will be they're final, so you need to say that the class is final. Sometimes you can make the subclass sealed, and then you're going to have subclasses of that one. There's a third case where you want to open up that particular one, in this case the custom shape, wants to allow any subclasses, wants to opt out of the sealing at that point in the hierarchy. And so there's a new non-sealed keyword for that. Record classes. If I were not able to write Java 17 code, record classes would be the thing that would motivate me to get on 17. So at the top of this slide, there's a one-line declaration of a class name, has a first name and a last name, two strings, and that's the entire declaration. If I were to write this with a class declaration, I would need to write some fields with those names. I would need a constructor that takes in those parameters and assigns to the fields. I would need accessors to return the values of the fields, just in case I want to have an extra layer of indirection to my field data. I would write toString and equals and hash code, because what makes two names the same is just whether the first and last match. So all of that code is gone. I don't need to write any of it. All I need to say is record. This is, in a sense, a boilerplate reduction feature, but it's also a conceptual feature. Anybody reading my code can see, oh, that's a name record. So I know what that means. What you do when you declare a record is you give up the ability to control your own fields, your own internal state. You declare, I have components, and you list your components with their names and types in the header of the record. And then the language manages the fields for you. If you need to do some customization, you can customize the constructor. I have an example here where I'm doing some validation. Even when doing that, I don't need to do the field assignments. The language takes care of the field assignments for me. And if I need to override a getter, in the vector example, I want to clone an array. And so I can replace the implicit getter with my own. I can also override toString equals hash code. So there's some flexibility there, but the basic concept is I have these components, and if you know what the components are, you know what this thing represents. Patterns. So much I could say about patterns. I've got 3 different JEPs all compressed into this one slide. the big idea of a pattern is that it combines a test. I've got a value and I want to test that it has a certain shape or certain properties. And then if the test succeeds, variable bindings. So every pattern expresses a test that can be true or false, and then has places where variables can be declared within the pattern. In the simplest form, a type pattern in my first example is just a type and a name. And if the data is of that type, then the test succeeds, it matches, and I get a variable with the given name. So this is just that feature alone is just a convenient way to do instance of foo. If instance of foo, then cast a foo. And we have to write code like that all the time. The pattern simplifies it, does the test and the declaration at the same time. Then we bring records into this. Records have components, and a record pattern knows how to get to the components. And so my second pattern in blue, this record pattern, says, first of all, is the data an instance of this record class? And if so, does it have components that match these nested patterns? Is the first one an instance of string? Is the second one an int? And if all of that is true, bind the variables. And so now I've got a pattern that introduces two variables at once in a really compact way. This is all through instance of. The other thing I can do with patterns is put them in switches. And so rather than just testing is it or is it not this one pattern, I can have a list of patterns. And whichever pattern matches first is the one that gets executed. Another thing to note about switch patterns is I said switch expressions have to be exhaustive. That exhaustiveness is able to take into account sealed classes. And so I'm working with my sealed class hierarchy you saw on the previous slide. And the compiler will check for me that I've handled all the cases. If I haven't, it'll let me know, and I'll have to go back and handle that extra case. Okay, so that's the 17 and 21 features. A lot of really great stuff. You're going to hear more as we move on about patterns and about records, kind of fundamental building blocks for a lot of what we want to do moving forward. Now let me switch to Java 25 features. There's 6 of these as I counted them. And they're a little bit smaller, but each are, I think, really useful and powerful. First one is markdown comments. I don't know if you want to count this as a language feature or not, but I kind of think it is because it's something you need to know when you're writing code. New kind of java.comment. Instead of /**, I'm using 3 slashes, ///. That signals to the javadoc tool that this is a comment that includes, that should be interpreted as markdown rather than the usual interpretation, which is HTML code. I don't think I need to sell people on the idea that it is more convenient and nicer to write markdown text than it is to write HTML text. So that's what this lets you do. All the usual markdown features are here. One thing to highlight is links work as links into the API. So I don't need to introduce footnotes with all the different pointers to different places I want to link to. I can just use class names and module names, use the hash method and hash field name features, and javadoc gives me those links directly. Unnamed variables, just let me name a variable with underscore, and what that says is this is not a name that I'm ever going to use. In fact, it's impossible to use the name. It's not in scope. There's nothing you could refer to. What do you do with that? It works on local variables, for loops, try with resources, catching exceptions, lambda parameters, pattern variables. All these are cases where there may be some sort of side effect that you want to achieve in the process of assigning a variable, but you don't really care what the variable is. And so you can just use the underscore. One other thing that comes with this feature is the ability on that last line to have an underscore represent a pattern within a record pattern. So it just means ignore this component completely. If I had a list of 5 components and I only care about one of them, all the other ones could be underscores. Flexible constructor bodies is an enhancement to the syntax of constructors and an enhancement to what you can do in the earliest phases of construction. So the syntactic change is that traditionally a super or this call, if you were going to explicitly include one of those in your constructor, has to be the first line of the constructor. You do have parentheses and then some expressions that execute before the call happens or as part of the call happening. And so sometimes people would write code that would have a dummy parameter to the delegated constructor. And the purpose of that code was just to do some side effect thing. And so that's an awkward way to get around this idea that you have to do the super or this first. This feature says it doesn't matter where you put the super or this. It has to be at the top level of the block, but you can move it down in your block as far as you want it to be. And then you can execute whatever statements you want before the super or this call. Then there's the semantic restrictions that go with this. In that code that happens early on in construction, you are not as free to work with this as you are later on in construction. It's useful to think about this. We usually imagine constructors working top to bottom. The object constructor runs first, and then the subclass, and onward until I get to the last class, and then I'm initialized. But what is actually happening is when I say new foo, I start in the foo constructor, and then I'm going to work my way up to the top to object, and then it's going to return back down. So there's the early side working the way up and the late side working the way down. On the early side, this sort of barely exists at that stage, and there's limited things you can do with it. In particular, you can't share it with other code. You can't invoke methods on it. The one thing you can do, which this JEP allows, is assign to the fields. And so I can set the fields in my constructor and then call super. And the advantage of doing that is it doesn't matter what the super call does with this. If my super constructor puts it in a database or something, or computes a hash code or a toString, my fields are already set, so I don't have to worry that they're going to try to do something that's going to access those fields that aren't initialized yet. So as an integrity move, we encourage people, as a best practice, to start assigning to fields early in construction rather than the late phase. I've got a talk tomorrow where I'm going to talk about immutable data, and I'll talk more about this. I wanted to highlight, so the blue part, that's the early construction. That all happens before the super call and goes up to the super. And then after the super in the super class, then we're working our way down. The orange part runs second. Module imports. It's a pretty simple concept. It's a new kind of import statement. When I say import module java.base, what I'm saying is import all 54 packages in java.base. And I get all the classes that are available in those packages. If I import java.sql, there's a couple of exported packages in that module, so I get both of those. I also get all the transitively required modules. Those get imported too. This is just a convenience feature. If you don't care about carefully managing your imports, then one import module gets you all the classes in Java base, and you can work with them, or whatever module you're using. Some people really prefer to enumerate all the classes explicitly, and that's a fine coding convention too. I want to validate that that's okay. But some people don't really care about that, and so there's a new tool in your tool belt. JShell now defaults to this behavior, so everything in Java base is available implicitly. Instance main methods are addressing sort of unnecessary overhead of declaring a main method, which may seem like it's one line of code, doesn't matter what you put in there. But when you're just starting out and you're writing Java programs for the first time, there's like 6 different things in the standard public static, void, main, string array, args that you would have to understand what that incantation means. And so you just write it and it's magic words. The move here is to simplify that, allow void main to be the declaration of your main method that's going to launch your program. If you need the arguments, you can add the argument parameter. If you want to add access control, you can, but any level of access other than private is fine for the method. And if you want it to be static, you can make it static, but you can also make it an instance method. That raises the issue, if it's an instance method, what is the instance? Where did that come from? So the launcher, as it sets up the program, normally it would load the class for you and then invoke main. So this is just an additional step. It's going to load, initialize the class. Then it's going to invoke a noarg constructor and create an instance, and then use that instance to invoke main. So it's just a simpler way to write a program when you don't need all the extra details. This is a simple HTTP server. I tested it, it works, I hope. You might add a few more lines if you were going to do it properly, like add the metadata to the response, things like that. But looking at that's a pretty small program that can do everything you need is sort of a hello world situation. Then we have compact source files, which is the same code, but I've just removed a couple of lines, so there's no more wrapping with a class around this code. It's just a top-level main method and a field and a few other things. So compact source files let you leave out the class declaration that wraps the contents of the class. There is still a class there, it just is invisible. Doesn't have a name in Java, so I can't do things like declare constructors. I have nowhere to put an extends clause. I can't create instances because I can't invoke a constructor. Really, the only thing you can do with it is use it as a launcher. So it has to have a main method. And then it can have as many fields and methods as you want. If it's an instance main, then you're going to get that one instance the launcher creates. From there's not a convenient way to make more instances. There's also a new I/O API, simplify, again, getting started situation. If I don't want to have to say system out print line, and even worse, system.in, take that and wrap it with something to get read line kind of behaviors. The I/O API is a simple way to do reads and writes. There was a demo earlier in the keynote of a one-line script using this feature. Maybe not 3-line script or something. You can also do shebang scripts with compact source files. There's a JEP. You can read more about how to make that happen. All right, that's it for the 25 features. Like I said, all sorts of great new things added to the language in 17, 21, and 25. The goal of making life easier for programmers, focusing on making things more declarative, more readable, less complexity and distraction. Now I want to switch to looking ahead, some upcoming features that are in the works. Big asterisk on this. Any feature that isn't targeted to a release is still in progress, still just an idea, may change. Even when it's a preview feature, it may change or it may go away. So be careful with assuming exactly all the details of these things. In particular, a lot of the syntax you see on these slides will probably change before it's a final feature. But a lot of big improvements in the pipeline. Improvements for records, improvements for classes, improvements for primitives, and improvements for arrays. So I'll run through some of those. First one is derived record creation. So I said that records express the essence of the object by saying I have these components, and that's essentially what I am. With that information, and with the fact that the record components are also the signature of a constructor, it's possible for the language to automatically extract the components, let me as a programmer manipulate those components, and then create a new one. And so that's what the derived record creation feature does. You've got an expression with a with keyword and then some braces. Inside the braces, that is my chance to take the components of the record, which are available as local variables, and manipulate them however I want. And when I'm done, the values that I've set get used to create a new instance. When you don't have this feature, what you're left doing sometimes is kind of tedious work of, I want to increment the third component of this record, so I need to extract all three components manually, and then invoke new foo with those three arguments, and it's all kind of tedious. And so this eliminates a lot of that overhead, also takes away the burden of the class author to try to think about what are the ways that somebody might want to map this thing to another thing. It can all happen at the use site. The user can decide what sort of mappings they want to do. Yeah, I think that's all I have to say about that one. Some other record enhancements. We'd like to make records support abstract superclasses, and those superclasses can also be records. What that means, obviously an abstract record can't be constructed, but if I've got three different records and they share some components, those shared components can go in the superclass, and then I can write some code at that higher level of abstraction and only work with the three different cases when that's necessary. When I declare my abstract superclass record, I list the components that are shared, and then in the subclass, the constructor automatically gets a supercall that will look at my components, match up, okay, this one has the same name and type, so that's the one that's going to get passed to the superclass. The other feature here is, like I said, it helps with integrity and safety to set fields before the supercall. So we'd like to make all records behave this way, to set their fields before the supercall. Most record constructors either don't exist at all, they're implicit, or they don't include the assignment logic that happens at the end. So the idea here is just to perform all the assignment logic and then do the implicit supercall at the very end of the constructor. That comes with the restrictions I mentioned. You can't use this in ways that you can after the supercall, and in almost all records, it doesn't make sense to try to be using this. So this comes as a feature. What this does is introduces a new kind of compiler error. That's what you see. But what you get is, in almost all cases, no errors, but at runtime, stronger integrity guarantees. And the VM can use those guarantees and optimize. Some record pattern related enhancements. One is the ability to assign to a pattern. I said patterns can be used in instance of to perform the test. Patterns can be used in switches if I want to perform a list of tests. If there's really no test to perform, because I already know it is one of these things, and I can even prove that with the type, then I can just assign it. And the left-hand side of the assignment, or it's a variable declaration statement. The left-hand side of the declaration is the pattern with all the variables that are going to get bound. And the right-hand side is just a single expression. As usual, right-hand side gets evaluated, then the assignment performs. The new thing here, instead of assigning to one variable, I've got a whole list of variables. The other thing on this slide is constant patterns. So sometimes when I perform a test, the test is for the special case where a component is an exact value, a component of a record. And so in a record pattern, we'll support numeric literals, strings, enum constants. And so if I'm looking for the 0.00 specifically, I can match on that one. Value records and value classes. This is something I could spend an hour on, but I'm just going to spend a couple minutes. There will be a new keyword, value. And what value indicates is that this record or this class does not need identity. For most records, that's true, and you should apply value when you declare it. For many classes that represent immutable data, that's also true, and you should declare it as a value class. What it means to not depend on identity is that instances of the class can't tell if they are different than another instance that happened to be created somewhere else at some other time, but it has all the same field values. So the essence of the thing is the field values. If the field values are the same, it's indistinguishable in every way from the other object. That means when you perform a double equals test, you're not going to get two different integers that have the same value but that are not double equals to each other. It's always the same. If it's the same int value that's stored inside the object, then they'll be double equal. There's no monitor here because identity, you need identity in order to be able to have a place in memory where you can store a monitor for the object. So there's no monitor, no synchronization, no mutation in general. You give up all those things, which in most cases, like I said, if you're modeling some data, you don't need. And in exchange, the JVM loves value objects and can do all sorts of different optimizations with those things, which is going to improve the performance of your code. It also eliminates an extra degree of freedom that you don't need, and so eliminates some risk of confusion if somebody misuses your API. Yeah, like I said, I could go on, but I think that's all I want to say about value classes and records. Class and interfaces, deconstructors, I'm sorry. As I said, there are different language features that have different capabilities, and when you switch from one to another, sometimes there's kind of this cliff that you fall off where you don't get any of that functionality. That's definitely true for records, and as we add more capabilities to records and record patterns, it becomes even more true. So the goal here is to bring some of those same capabilities to other classes and to interfaces. The syntactic feature is to take a list of components, as you see in records, and put that immediately after the interface name or the class name. And that says these are the essence of what this thing represents. It is also a promise that those three names and types are going to be three different accessor methods in my declaration. So as a minimal interface that has some components, I need to declare three different methods for those three components. It doesn't say anything about construction. I don't get any bonus accessors or toString and equals and hash code. None of that comes with records. This is just a statement about what is this data composed of. And by making this statement, now I've unlocked the door to everything that record patterns can do. So I can have deconstructor patterns that get at those components. I can do, if I have a constructor that with a matching signature, I can do the with expressions, which are going to deconstruct the object and then reconstruct it at the end. I can do the assignments to patterns. All that stuff is available because of the semantic statement about the components. Some other class enhancements. These are less nailed down, I think. So next time you see these features, they'll probably look a little different. Interface witnesses. This one just needs a better name. The idea with this is think about the comparator interface. It is not an interface that an object would implement to say, I can compare myself to other things. That's comparable. But what comparator does is it's a behavior type. Implement comparator, it's a function that says, how you can compare two of these things. The new feature here with the witness keyword in this example is for a class to say, this is the canonical way that I want you, the canonical comparator that I recommend using when working with this class. That's not that useful for comparators because we already have comparable. But a lot of applications for this are things like operators, so plus, minus, and divide, and multiply. That's something that could be expressed with an interface like comparator that says, here's the arithmetic operations that something supports, and then a class could publish, here's how you do arithmetic with my class. Also things like conversions, collection literals. We've had a lot of sort of ideas of surface features that we could do an ad hoc thing to provide, and it always feels a little unsatisfying. And we've realized this feature here is the building block. This is the primitive that you need to unlock those sorts of behaviors. If a class can publish, here's how you work with me, then all these other features can be built on top. The other thing on this slide is null-checked fields. The idea is that a class can declare a field non-null, and that means it can never store null. So it doesn't have a default value, which means it needs to be initialized with something. For integrity reasons, that has to be initialized early. There might also be some memory model impacts of this statement. But when I'm using it, I can't assign nulls. I'll get an exception. And with that information, again, this is a like opt out of some things, gain some things. Opt out of the ability to put null in this field. The JVM then can optimize the layouts of value objects in this field much better than it could, in some cases, better than it could if the field were nullable. All right, I got two more families of features. This one is primitive types. Next one is arrays. Primitive types, sort of the thematic theme here, the thematic thing, what we want to do with primitives is let them support some of the behaviors of classes. So for example, with value classes, the classes integer, double, etc., become a lot cheaper to, the boxing to those types becomes a lot cheaper, and so the difference between int and integer is a lot smaller, and it makes sense for the language to more freely just let you box when it makes sense. And so examples of doing that is in overriding. I could have a method that returns an int, and it's understood that overrides the method that returns integer. I could have method invocations. So in my example here, there's a is not a number method of double that could be invoked on the primitive type double. And then the other thing on this slide is extending instance of and patterns to primitives. The intuition there is to understand that primitives allow casts from one type to another. Some of those casts are destructive, you lose information. Some of those are not. Any of the non-destructive casts are conversions that are safe to do, and therefore, when I say instance of int, it makes sense to say, can this thing be converted to an int in a safe way? And so this is a preview feature in 26. It's been a preview feature for a couple of releases. This will allow working with primitives to get a little easier. Last one, array enhancements. Again, this goes back to the declarative, not imperative item on my list of themes. So we'd like to introduce a new kind of array creation expression that is declarative, that says, here's how to fill in all the elements. Usually when you create an array, you allocate the array, and then you have a for loop, and you one by one assign to the components. And that can get tedious. It's also, I keep saying the word integrity. It's not as safe because if you accidentally expose that array to somebody while you're initializing it, then they'll see the uninitialized data, and it may not represent the thing it's meant to represent. So if it fits to express the creation with something like a lambda, that is a cleaner and simpler way to declare your array. It is also a necessary thing to get to the next feature, which is final arrays. So my second line here has a final array of doubles. That means what you would think it would mean. Each component in the array is immutable. Somebody can't come back and manipulate it later. And in order to have a final array, I need to initialize all the components to something. So the lambda there expresses that. Same idea with non-null arrays. We saw non-null fields on the previous slide. If we have non-null arrays, I also need to initialize the array to something. And I think that's all I want to say here. Okay, wrapping up. Let me go back to my list of themes, see if you recognize some of these in the different features. Preserving the feel of Java, minimizing disruption. The way this kind of manifests often is maybe you know a feature from a different language and it looks different. We try not to just make arbitrarily different choices for the sake of being different, but we try to make choices that help features fit in with Java as it exists. Making it easier to work with immutable data. A handful of different examples of that. Everything to do with records and patterns is focused on immutable data. Being more declarative, less imperative. We saw a lot of those kinds of features. Minimizing the seams, helping primitives be more like classes, helping classes behave more like primitives, helping arrays get some of the features that classes have. And then last, reducing activation energy. We saw a handful of features that are just meant to simplify the code so you can say what you mean and not get distracted by extraneous details. That's all I've got. I have pointers here to the Valhalla project and the Amber project, along with the JEPs that I mentioned in the slides. If you'd like to follow along with the new developments, check out those projects. And I could probably take a couple of questions before we're out of time. If anybody has some questions, just come up to the mic.
Hi, so the non-null modifier is a replacement for the bank character or are not related?
Yeah, so you're familiar with some earlier discussions about the exclamation mark character. We're just playing with syntax. It's all the same thing, yeah.
Okay.
And next time you see it, it'll probably look different again. But we've been playing with just different ways to express the same concept. Yeah.
Okay.
Come on up to the microphone.
Hi, two questions. One, I assume there is backward compatibility through and through in all of this work. Mm-hmm. Has that posed any challenges, especially on performance? And second, can you get access to the slides? I think it's a really good way of us kind of present these updates to other people, let's say,
right.
at my work at school.
To that question, I will share my slides with the organizers, and I don't know what they do with them. I think there is a way to get to them. At the very least, I know the videos will be published, and you'll be able to see the video. First question was about what challenges does backward compatibility face? So as a minimum, just the way these things work is it's always a new feature moving forward. We never try to backport language features to older versions. And so that's the discipline we follow. It's always evolving the latest version of the language. As we make changes, there's two things. One is, let's look at switches, for example. That's going to take a long time if I do one by one. Switches. Almost there. There we go. Okay, switches. There was some discussion about, do we want to introduce a new feature that does this thing, or do we want to reuse the switch? And if we reuse the switch, how do we deal with all of the legacies of switch that we don't like? So for the most part, the idea that we took was to keep switch, add some things to it, let people choose, do I want to use the new thing or do I want to use the old thing? There are some subtle changes. You can always use an old switch, but as we added like new capabilities, for example, switching with patterns, we made some changes and said a pattern switch needs to be exhaustive even for a switch statement. So that was a choice to break sort of the consistent, compatible thing to do in order to nudge the language in a better direction. All right, anybody else? I'll take one more. We are good. Okay, thank you all.